Hello everyone and welcome back. Today we are going to be working on a Kaggle dataset which I mainly found from the site Kaggle. Now the main question is how do you import a dataset? You can see this mini file over here on the site. You're going to click on it and as you can see there is an upload to session storage. Now when you click on it there's going to be a list of filed options that you want to upload. I have created a sample folder for these Kaggle dataset and stored them in there. From from that folder, I can easily access any of my datasets which I would like to import. Now let's get started with the main thing. Now first of all, for this dataset, you're gonna import few main libraries, which is gonna be pandas as PD, matplotlib.pyplot as PLT, numpy as NP, and from stats model to say seasonal, we're gonna import seasonal decompose. Now before starting any of the main practices, we're gonna do a few of logical things. For example, like reading our file into the computer, so the computer can understand which dataset we're working with. We're gonna print the first 12 rows and the last 12 rows. Because since it's like a monthly dataset and there are 12 months in a year, I was like, why not print it from January to December? The dataset I'm working with is mainly talking about the sales of a shampoo over a 3-year period. As you can see from January to December, there is this number beside it given as 1. This indicates that these months are included in the 1-year period. And the 3 months, the months which have 3 besides them indicate the 3-year period. After printing the top 12 and the last 12 rows, we're going to print the shape of the data and the information about the column. The shape is basically 36 to 2, means there are 36 columns and there are 2 rows. And here we have our index, which is our information about the columns. Now, since you don't want to working with all of these dates over here, I selected few of them and stored them in a variable called month. And sales is going to be data sales of shampoo over 3-year period, and we're going to add our I for I in zeros 1, 6, 12, 22, 27, 26, and 35. Now what are all these numbers for? As you can see, I've chosen 1st of Jan, and 1st of Jan is the first column. And here we have 22. Let's take 26 for now, and 26 is actually 3rd of March. And just like that, we're working in correlation. Now we're going to plot our graph by using plt.plot months and sale. The X label is going to be month, which is the vertical, and Y label is going to be sales of shampoo, which is horizontal. And our title for the graph, it's mainly optional, and I would like to give it sales of shampoo 3-year period. Now we're going to show our graph, and this is our output. This is 1st of Jan. This is a day trend. This is 1st of February. It's going up and stops at 1st of July. And December, it's actually decreasing a bit. But then taking a hit in 2nd of June. And here you have our biggest qualification yet, which is on 2nd of November. You move on to 3rd of March, which takes it downhill, and 3rd of December is the most productive year of these 3 ones. Now we have our graph. We're going to do the multiplication decompose and the additive decompose, which I explained in my last video regarding time series. Here we have multiplication decompose, in which we're going to enter our sales of shampoo 3-year period, because this is the thing which we want to work with. And since it will pose an error if we do it without the period, we're going to add period. Period is a set of time which we want to indicate. And since our month is for 1 year, we're going to enter the period as 12, which indicates 12 months in 1 year. You're going to do the same thing for additive decompose with the period as 12, and as you can see, these are our outputs. This is the normal time series dataset. This is the trend separated. This is the seasonality, and this is the residual, which is not everything captured by trend or seasonality. Here it's pretty much the same, but not same as well. Because this is the trend, I see some difference. And then there's the seasonality and the residual. Let's compare them side by side. And let's now compare them side by side. As you can see, this is the original dataset that we have. The trends are almost pretty much similar. So is the seasonality. I mean a bit. Because as you can see, this is the first point. And this is our first point in the additive. So this is multiplicative and this is additive technology. And you can also see in the end how this is a perfect curve, perfect point actually, while this is a bit rotated. This is the difference. We have difference between seasonality and residual. As you can see, our line of 0 is actually on the bottom, while this is in the middle, and the data points are scattered all over. While for multiplicative, it's only scattered in the above between 0.5 and 0.1. Next, we're moving on to how to log transform the dataset. Now, log transforming actually means distributing the dataset over our main graph. So we're going to do all the details. For example, data log is equal to data copy. We're going to enter our column which we want to transform, and here we're going to be using NumPy library. We're going to plot the data set and show it. Now here we're just creating the subplot like 2, 1, 1, and the title, this is original time series. We're going to compare them together. For example, the original time series, this is going to be sales of shampoo over a 2-year period, and we're going to plot another graph right below it, which is log transform time series, in which we're going to show our transformed data set. This is the original data set right over here, and this is the log transformation data set. Now, since our data set is not that in necessity of distributing the data points, there's no difference, there's not much difference between the log transformation data set. And thank you so much for watching. I'll be seeing you in my next video.